NASA's SpaceX Crew-10 mission took flight from the Kennedy Space Center in Florida on March 14, 2025, marking a significant milestone in the ongoing efforts to maintain a human presence aboard the International Space Station ISS. The Falcon 9 rocket launched at 7:03 p.m. Eastern Daylight Time, carrying a diverse crew of 4 astronauts, NASA's and McClain and Nichole, Ayers, Japan's Takuya Onishi, and Russia's Kirill, Peskov. This mission is particularly notable as it signals the impending return of 2 NASA astronauts who have spent an unexpected 9 months in orbit. The Crew-10 launch follows a previous scrubbed attempt just 48 hours earlier, which was halted due to a ground system issue. This mission is a testament of what humans can achieve when we work together. Go Crew-10 Ayers communicated to mission control moments before liftoff. The rocket's ascent was smooth, with the 9 Merlin engines burning through 1 million pounds of propellant in just 3 minutes, propelling the crew into low Earth orbit at speeds of 17,000 miles per hour. The crew aboard the Dragon spacecraft is expected to autonomously dock with the ISS approximately 28.5 hours after launch, scheduled for 11:30 p.m. Eastern Daylight Time on Saturday, March 15. Their arrival will kick off a handover period, allowing the new crew to acclimate to ongoing scientific experiments and maintenance tasks before the outgoing team departs for Earth. Among the outgoing crew members are NASA astronauts Suni Williams and Butch Wilmore, who have gained considerable media attention due to their prolonged stay aboard the ISS. Initially intended to remain for only a week during the first crewed test flight of Boeing's Starliner spacecraft, their mission extended dramatically after the vehicle faced significant technical issues. A decision was made to return the Starliner without astronauts on board, leading to their reliance on SpaceX's Dragon capsule for the eventual journey back home. This situation has sparked discussions in political circles, with some claims suggesting that delays in their return were influenced by political motivations. Notably, both SpaceX CEO Elon Musk and former President Trump have made unverified assertions regarding the Biden administration's role in the astronauts' extended mission. However, NASA has consistently planned for a SpaceX vehicle to facilitate their return. As Crew-10 embarks on its mission, it not only represents a routine rotation of astronauts to the ISS but also highlights the complexities and challenges of human spaceflight. With McClain and Onishi returning for their second flights and Ayers and Peskov embarking on their inaugural journeys, this mission embodies the collaborative spirit of international space exploration. Looking ahead, the space community will be closely monitoring the Crew-10 mission as it progresses, particularly as it facilitates the long-awaited return of Wilmore and their colleagues. Their eventual homecoming, anticipated as early as March 19, will conclude an extraordinary chapter in human spaceflight history, setting the stage for future missions and advancements in our exploration of space. In a significant advancement for human space exploration, NASA's SpaceX Crew-10 mission successfully launched on the evening of March 14, 2025 at 7:03 p.m. Eastern Daylight Time from Launch Complex 39A at Kennedy Space Center, Florida. This mission not only marks a milestone as the 10th crew rotation under NASA's Commercial Crew Program, but also serves a crucial purpose, relieving 2 astronauts who have been stranded aboard the International Space Station ISS for 9 months. The Falcon 9 rocket propelled the Crew Dragon spacecraft into orbit, carrying a diverse team of astronauts, NASA's and McClain and Nichole, Ayers, Japan's Takuya Onishi from the Japan Aerospace Exploration Agency JAXA, and Kirill Peskov from Roscosmos, the Russian space agency. The spacecraft is scheduled to dock with the ISS's Harmony module autonomously around 11:30 p.m. on March 15, 2025, allowing the Crew-10 members to join the ongoing Expedition 7273. NASA Acting Administrator Janet Petro expressed her enthusiasm for the mission, stating, "This milestone demonstrates NASA's continued commitment to advancing American leadership in space and driving growth in our national space economy. Through this partnership with SpaceX, NASA aims to lay a solid foundation for future explorations beyond low Earth orbit, including missions to the Moon and Mars." The Crew-10 astronauts are expected to conduct a variety of scientific experiments, including material flammability tests, engaging with students worldwide through the ISS ham radio program. and studying physiological and psychological changes in the human body, all essential for preparing for deep space missions. The launch's significance is compounded by its role in facilitating the return of astronauts Butch Wilmore and Suni Williams, who have faced an extended stay aboard the ISS due to a series of technical challenges. Originally expecting to complete a brief mission, the duo's return has been delayed due to issues with their initial spacecraft Boeing Starliner. NASA ultimately deemed it safer to bring them back via SpaceX, marking a pivotal transition that underscores the complexities of modern space travel. As the Crew-10 members prepare for their 6-month stint in space, the overlap with Wilmore and Williams is crucial. It will allow the outgoing astronauts to debrief their replacements on the ISS's current operations and research, ensuring a smooth transition. Wilmore and Williams are expected to undock next week with plans for a return splashdown off the Florida coast contingent on favorable weather conditions. In a poignant reflection, McClain, who commands Crew-10 and is on her second trip to the ISS, remarked, "Spaceflight is tough, but humans are tougher." The resilience of astronauts like McClain, Ayers, Wilmore and Williams highlights the human spirit's determination to push the boundaries of exploration even in the face of unexpected challenges. With the Crew-10 mission now underway, NASA continues to maximize the potential of the ISS, which has been continuously inhabited for over 24 years. The research conducted aboard the station not only benefits life on Earth but also paves the way for future missions aimed at deeper space exploration. As the world watches, the collaboration between NASA and SpaceX stands as a testament to the advancements in space travel, fostering global interest in the pursuit of knowledge beyond our planet. Looking ahead, the successful integration of new technologies and international cooperation will be vital as humanity embarks on its next great adventures in space, including the ambitious Artemis program that aims to return humans to the Moon and eventually reach Mars. In a remarkable turn of events for two NASA astronauts, the long-awaited crew swap mission has successfully launched, bringing them one step closer to returning home after an unprecedented 9 months aboard the International Space Station ISS. This mission, executed by SpaceX, has not only underscored the complexities of space travel but also highlighted the resilience of human ingenuity in the face of unforeseen challenges. The SpaceX Falcon 9 rocket took off from NASA's Kennedy Space Center in Florida on March 14, 2025 at 7:03 p.m. Eastern Time, carrying the Crew-10 members, which include NASA astronauts and McClain and Nichole, Ayers, Japan's Takuya Onishi, and Russian cosmonaut Kirill Peskov. This crew, set to embark on a routine 6-month rotation, is expected to dock with the ISS around 11:30 p.m. Eastern Time on March 15, providing a critical overlap period for the incoming and outgoing teams. NASA astronauts Butch Wilmore and Suni Williams, who have been stationed in orbit since June 2024, were initially slated for a brief 10-day mission. However, mechanical issues with their spacecraft led to a series of delays, forcing them to remain aboard the ISS far longer than anticipated. After extensive troubleshooting, their return vessel was ultimately sent back to Earth without them, leaving both astronauts in space, while their homecoming was repeatedly postponed due to ongoing technical delays. In a statement reflecting on their extended stay, Wilmore expressed both gratitude and anticipation. "While we are proud to contribute to ongoing research and operations aboard the ISS, we are eager to reunite with our families and friends on Earth after what has been an extraordinary journey." His sentiments resonate with the challenges faced by astronauts who often encounter unexpected circumstances beyond their control. The return journey for Wilmore and Williams is scheduled for March 19, 2025, alongside NASA astronaut Nick Hague and Russian cosmonaut Alexander Gorbanov. The planned overlap of crews is designed to facilitate a comprehensive briefing for the new team, ensuring a smooth transition of responsibilities aboard the space station. This mission is not only a logistical achievement but also a testament to the collaborative efforts of NASA and SpaceX. As the space industry continues to evolve, the complexities of human spaceflight highlight the need for robust contingency plans and rapid problem-solving capabilities. The ongoing partnership between governmental and private entities is essential in pushing the boundaries of exploration and ensuring the safety and well-being of astronauts. Looking ahead, the successful launch and anticipated return of the astronauts will likely open discussions around the future of crewed missions in low Earth orbit and beyond. As technology advances and more ambitious projects are planned, the lessons learned from this experience will undoubtedly inform strategies to mitigate risks and enhance the safety of future space travelers. The journey of Wilmore and Williams serves as a poignant reminder of both the challenges and triumphs inherent in human spaceflight, as well as the indomitable spirit of exploration that drives us to reach for the stars. In an exciting development for lunar exploration, NASA's ongoing research aboard the International Space Station ISS is proving to be invaluable for upcoming missions to the Moon. On March 2, 2025, Firefly Aerospace's Blue Ghost Mission 1 successfully landed on the lunar surface, marking a significant milestone in space science and technology. This mission is not only a testament to advancements in space exploration but also illustrates the critical role that the ISS plays as a testbed for new research and technologies that will pave the way for future explorations beyond Earth. The Blue Ghost mission is deploying 3 key experiments that were either developed or refined through research conducted on the ISS, providing insights that are essential for navigating and surviving the harsh environment of the Moon. Among these is the Lunar Environment Heliospheric X-ray Imager LEXI, a small telescope designed to investigate the Earth's magnetic environment and its interplay with the solar wind. LEXI, akin to the neutron star interior composition explorer NICER mounted on the ISS, aims to provide a deeper understanding of how the solar wind interacts with Earth's magnetosphere. This knowledge is crucial as it may lead to improved methods for protecting future lunar infrastructure from space weather phenomena. Another notable experiment from Blue Ghost is the Radiation-Tolerant Computer System RAD-PC, which seeks to evaluate the resilience of computer systems in the Moon's radiation-laden environment. Prior testing aboard the ISS has enabled researchers to develop algorithms that can detect hardware faults and facilitate self-repair. The ability to maintain computer health in real time could significantly enhance the reliability of technology used in deep space missions where failures can have severe repercussions. Additionally, the Lunar Global Navigation Satellite System GNSS receiver experiment LUGRE has made history by successfully receiving GNSS signals at a record distance from Earth. This feat mirrors the navigation systems that are ubiquitous on Earth, from smartphones to aircraft, and signifies a step toward establishing reliable navigation on the lunar surface. The Navigation and Communication Testbed NAVCOM aboard the ISS has been simultaneously working on alternative lunar navigation solutions, further bridging existing Earth-based systems with the unique requirements of lunar missions. As the ISS continues to serve as a vital platform for research and technological advancement, its contributions extend beyond immediate scientific inquiries. Each experiment conducted aboard the station not only enhances our understanding of the universe but also lays the groundwork for future explorations of the Moon and ultimately Mars. The knowledge gained from these early missions will inform strategies for safe human exploration and sustainable habitation on other celestial bodies. Looking ahead, the integration of these technologies into forthcoming lunar missions will be crucial. NASA's commitment to leveraging ISS research underscores the importance of international collaboration and innovation in the pursuit of deeper space exploration. As the agency prepares for a return to the Moon under the Artemis program, the findings and developments resulting from current research will undoubtedly shape the future of space exploration, offering exciting possibilities for scientific discovery and human presence on the Moon and beyond. In a significant leap for Martian exploration, NASA's Curiosity rover has recently captured images of peculiar rocks on the surface of Mars, showcasing unique textures that have piqued the interest of scientists. As the Mars Science Laboratory mission progresses into its winter phase, the rover continues to unveil the geological mysteries of the Red Planet. The images taken on March 12, 2025 during Sol 4478 reveal two rocks dubbed Manzana Creek and Palo Comado exhibiting textures unlike anything encountered in the mission's history. According to Ashley Stroop, a mission operations engineer at NASA's Jet Propulsion Laboratory, the team is eager to analyze these formations, which might hold crucial information about Mars' geological history. Curiosity's current activities revolve around targeted imaging and analysis of these intriguing rocks. The rover's ChemCam is scheduled to make laser-induced breakdown spectroscopy LIBS observations of a nodule named Sturtevant Falls among other targets. This method involves firing a laser at the rock, vaporizing a small sample to analyze its elemental composition. The findings from these analyses could prove invaluable as scientists seek to understand the environmental conditions that shape these Martian formations. This exploration comes on the heels of another discovery by NASA's Perseverance rover in Jezero crater, where pale float rocks revealed through similar spectroscopic techniques suggest that Mars may have once experienced warm, wet conditions conducive to life. Planetary scientist Roger Wiens from Purdue University noted, "These rocks are very different from anything we've seen on Mars before, they're enigmas." The composition of these rocks includes kaolinite, a mineral that typically forms in warm, wet environments, highlighting the potential for ancient habitable conditions on the planet. The implications of these discoveries extend beyond mere geological curiosity. They raise fundamental questions about Mars' past, particularly regarding its water history. The big questions about Mars are about water. Wiens commented, emphasizing the need to understand the extent and duration of water presence on the planet. As the exploration missions gather more data, they could ultimately reshape our understanding of Mars and its potential to support life. Amid these scientific endeavors, the political landscape surrounding Mars exploration is also evolving. In his inaugural address, President Donald Trump signaled a potential shift in priorities towards Mars missions, suggesting that the red planet may become a central focus for NASA in the coming years. This strategic pivot raises concerns about balancing funding between Mars initiatives and ongoing lunar projects such as the Artemis program, which aims to establish a sustained human presence on the Moon. As the U.S. positions itself in the race for Mars exploration, international competitors, notably China, are ramping up their own efforts. China plans to launch its Tianwen-3 mission by 2028, targeting a sample return from Mars ahead of NASA's anticipated timeline. The urgency of these developments underscores the stakes involved, not only in scientific discovery but also in national prestige and security. Looking ahead, the successful execution of NASA's Mars Sample Return (MSR) mission is critical. With plans to bring Martian samples back to Earth for detailed analysis, this mission could provide definitive evidence of past life on Mars, potentially one of the most significant discoveries in human history. However, the financial and logistical challenges ahead remain daunting, and NASA will need to carefully navigate its resource allocation to ensure progress. As Curiosity continues its exploration, the data it collects will contribute to a deeper understanding of Mars' history and prepare humanity for future endeavors on the planet. The coming months will be crucial as NASA and its international counterparts embark on missions that could define our understanding of life beyond Earth and the future of human habitation on other planets. In a remarkable intersection of science and celestial phenomena, NASA has confirmed the successful operational status of Firefly Aerospace's Blue Ghost Mission 1, which has been navigating the lunar surface since its landing on March 2, 2025. As part of NASA's Commercial Lunar Payload Services (CLPS) initiative, the lunar lander has delivered 10 sophisticated science and technology instruments to the Mare Crisium Basin, all of which are now active and collecting valuable data. On March 14, Blue Ghost captured stunning images of a total lunar eclipse from the Moon's surface, providing a rare perspective of this astronomical event. The images show the Moon transitioning into a striking red sphere, commonly referred to as a blood moon, as Earth's shadow enveloped it. This unique observation underscores the dual significance of the mission. Not only is it gathering critical scientific data, but it is also documenting celestial events in real time. Among the payloads successfully deployed by Blue Ghost, the Lunar GNSS Receiver Experiment LuGRE has achieved a significant milestone by tracking Global Navigation Satellite System GNSS signals, an unprecedented feat for lunar operations. This advancement could pave the way for improved navigation solutions for future lunar missions leveraging systems like GPS and Galileo. Firefly's mission also includes the Lunar Environment Heliospheric X-ray Imager LEXI, which has been capturing X-ray images to study the interactions between solar wind and Earth's magnetic field. Insights gained from LEXI will enhance our understanding of how space weather influences terrestrial conditions. Another noteworthy instrument is the next-generation Lunar Retroreflector NGLR, which has successfully returned laser light from 2 lunar laser-ranging observatories. This technology allows scientists to measure the Moon's shape and distance with unprecedented precision, contributing to a deeper understanding of its inner structure. The Lunar Magnetotelluric Sounder LMS is examining the Moon's interior by deploying 5 sensors to measure electric and magnetic fields, allowing researchers to analyze the Moon's composition and structure down to depths of over 700 miles. Similarly, the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity Lister has become the deepest robotic planetary subsurface thermal probe, showcasing innovative excavation techniques that could revolutionize subsurface exploration on other celestial bodies. In addition to these instruments, the stereo cameras for Lunar Plume Surface Studies scalps have documented over 3,000 images during the landing phase, providing critical data on how engine plumes interact with the lunar surface. The Lunar Planet Vac LPV has successfully demonstrated a low-cost method for collecting lunar soil, while the Electrodynamic Dust Shield EDS has shown promising results in mitigating lunar dust, a significant challenge for future missions. As the Blue Ghost mission continues to unfold, the radiation-tolerant computer RAD-PC has verified its resilience against radiation as it operated through the Earth's Van Allen belts and on the Moon's surface. This validation is crucial for ensuring the safety and efficacy of future missions in similar environments. The intersection of these scientific advancements and the spectacular display of the lunar eclipse highlights the ongoing commitment of NASA and its partners to expand our understanding of the Moon and the broader universe. As NASA continues to push the boundaries of space exploration, the insights gained from the Blue Ghost mission will undoubtedly inform future lunar missions, including those planned under the Artemis program. As we look to the future, the next total lunar eclipse is anticipated in September 2025, promising further opportunities for captivating astronomical observations from both Earth and beyond. With the successful operation of the Blue Ghost mission, we can expect even more innovative approaches to lunar exploration and a deeper understanding of the cosmos.